Hi, in this video I'm going to explain how to solve a problem involving Pythagorean theorem. This is not the usual Pythagorean theorem wherein you're given a single triangle and all you have to do is to compute for the missing side of the triangle. So it says the figure shows a closed rectangular box. Given that determine the measures of AC, the measure of angle CAF, and the measure of AF. Let's start with letter A. We want to find AC. Okay. So this is AC. So we need to locate AC. So this is AC or CA. Now if I want to compute for that, I need to determine a triangle that contains AC. And there are many options actually. You can have CDA, you can have CFA, or you can even have CBA. The key in deciding which triangle to use is that since this is an application of the Pythagorean theorem, you have to find the triangle that contains two known values, because you can only use Pythagorean theorem when there is only one missing side. Okay, so just in case you don't recognize, you have to know that this is a rectangular box, so the angles formed at many parts of the triangle are 90-degree angles. Okay, some are not obvious, like this one is 90 degrees. Okay, so if I have to use a triangle with two known sides, I can use triangle CDA. Okay, so even if the number here is not given, I can easily say that this is 12, because the sides of a rectangle, or the opposite sides of a rectangle, are the same. So if the side BA is 12, then the side CB must also be equal to 12. Okay, so this is a 3D object. The angle doesn't look like a 90-degree angle on D, but that's actually a 90-degree angle. So when I recreate the triangle CDA, so this is C, this is D, and this is A, this is 9, and this is 12, then the CA is this side, which is the hypotenuse. So using the Pythagorean theorem, I have 12 squared plus 9 squared is equal to x squared. Always isolate the hypotenuse on the other side. Okay, so that is x squared. So just compute 12 squared. This is 144 plus 81 equals x squared. If you add 81 and x squared, that will be equal to 225. And to get x, all we have to do is to get the square root of 225. Okay? Formally, this is plus or minus square root of 225, but since it's a measure of a side of a rectangle or a triangle, then we can only take the positive value of it. Okay, so the square root of 225 is equal to 15, so x must be equal to 15, and that's the measure of AC. Okay, so the units is cm. Okay, so that's the answer for letter A. Now let's proceed to letter B. Calculate the value of the angle CAF. So you have to get the triangle containing the angle CAF, and that is basically the triangle CA and the F. Again, a while ago I said there are some angles there hidden, and they are not obvious, it's not easy to see that they're actually 90-degree angles. So, for example, FCA angle, or angle FCA, is a 90-degree angle. Okay, so if I want to find CAF, so that's CAF, so this is the angle that we need to find. So let's call it as Y. Okay, then try to determine the known sides of this triangle. this is 5 because the height of the rectangular box are all the same. So this is 5. And AC or CA was solved in part A of the problem, and that is 15. Okay. Now, if I want to find the angle Y, then I should use the concept of Sohcahtoa and determine which functions should I use to solve for Y. Looking at the sides, 5 is opposite and 15 is adjacent. So my option should be tangent. So if I set up the tangent equation, tangent of y, the angle y, is equal to 5 over 15. And to get the y, if I want to get the y, all I have to do is to get the inverse of the number 5 over 15. If I will do that, so I have 5 over 15, to get the tangent inverse of the answer, that is 18.43. So this is 18.43 degrees. So the measure of CAF is 18.43 degrees. Okay, finally, we want to calculate the measure of AF. So AF is also the side of the triangle CFA or ACF or FCA. And the two sides are already given, so all I have to do is to use the Pythagorean Theorem. So using the Pythagorean Theorem, I have 5 squared plus 15 squared is equal to FA, let's call it Z, so Z squared. So this is 25 plus 225 is equal to Z squared. 225 plus 25 is 250, so this is Z squared. So Z must be the square root of 250. Okay, so the square root of 250 is equal to 5 square root of 10, or in decimals, this is 15.81. Okay, so this is 15.81. Okay, so that's the measure of FA or AF. Okay, this is equal to AF. Okay, so I hope you were able to follow my explanation on this particular problem. Just one thing to note, the most crucial part of solving this problem is to recognize the 90-degree angles there, because it's not easy to see that they're actually 90 degrees. Like in the case of FCA, it's not too obvious that it's a 90-degree angle. So in addition, when you use the Pythagorean theorem, make sure that the isolated value is the hypotenuse of the triangle. And you can only use the Pythagorean theorem when two sides are given and one is missing. For the case of finding an angle, it always rely to the Sohcahtoa because you're using right triangles here. To determine So, Ka, or Toa, you have to check which sides are given so that you will know, or you can decide if it's a sine, a cosine, or a tangent. Okay, so I hope that is clear. That's the last example for the applications of trigonometry. So there are other videos that will contain problems that are harder than these examples that I have shown you. Okay, that's it. Thank you.